Hello everyone. As promised, I want to show you another video of creating a map, but this time instead of using a robotic arm or manipulator, we are going to use a mobile robot. And the mobile robot we are going to use is the Quanser Qbot2. This is the older generation. The newer ones we have not purchased yet, but hopefully we will at some point. And these guys, as you know, they have a Kinect on them. So they can give you images as well as range data between 0.5 meter to 5 meters. The camera gives you images with 480 by 640 pixels. The field of view for your camera in the horizontal direction is 57 degrees. So here we are going to create a 2D occupancy grid map with this robot as it goes around in this kind of environment that I made for it. So on this big table, I put a bunch of different objects. So this robot is going to go on a small circle and goes around several rounds and scan them, and any object that is at the same height as its Kinect, it is going to get it. Now, since it can go up to 4 meters, in the gaps between these objects, it is going to go all the way to the walls, and so you're going to see two layers. One closer layer, which are these objects, and then between their gaps, it goes all the way to 5 meters, and it can catch some of the walls in the back of the room. So let's go ahead and see how to use the software for this robot, which is called Quark. Quark is a piece of software that sits on the top of MATLAB Simulink. So when you install it, you see here now you have an extra tab called the Quark. And this Quark has different blocks that you can use to run this Qbot. So the system here is a hardware in the loop. So a bunch of blocks that you see are called HIL, which is hardware in the loop. And the files that you save in Simulink, they are not going to be SLX, they are going to be MDL, they are models, okay? Because you have a physical system that you run with this Quark. So the first block that you need in all of them is this guy called the HIL initialize. This has to be in all of them. You don't need to change anything about the setting of it, but you see here you can, for instance, because Qbot is only one of the robots that Quanser makes. They make lots of other robots. So you see there are other robots, and you pick the robots that you want, and then there are other settings. You typically don't need to change them or do anything. If you use the data from the Kinect, the depth sensor or the camera, then you have to use this block here called Kinect initialize. Again, you don't need to change anything for it, but if you want, you can, right? So you see here, this is the Kinect initialize, and then you have the Kinect get depth. So this one is to get depth, read the laser data from the Kinect. There is another one which is for getting images. Okay, I can show you that one as well. And if you want to know more about what kind of blocks the Quark adds to the Simulink, then go to the library browser under Simulink, and then you can see this branch called Quark targets, and then under that you have advanced, continuous, all sorts of things. If you go under multimedia, that is where you can see the stuff that we have. So look here. We have Kinect get image, and remember this one that was Kinect get depth. And if you go back here and look at it, as I told you, the image size is 640 by 480, and that also applies for the depth map image size, and you can change that to smaller ones if you want to go faster. So here you get your depth, and you can send it for processing and creating the basically occupancy grid map, which this block is doing. By the way, all of this model that you see here is all done by Quanser company. I have not made this. I can make it if I want to, but I'm using the ones they already built, so it doesn't take a lot of time. But here is basically your model from Quanser. They have all sorts of processing blocks too. You see here, these are the blocks they have for image. So in my next video, which is going to be about line following, if you want to only look for a specific color of a line on the ground and kind of follow that, you need to do a color thresholding. And if you want, you can use the blocks here, or you can use generic blocks in Simulink. But know that Quanser Quark software has some blocks for you for different kind of processes. Now, if I go back here to my Simulink model, you see here that I have a command here, and the command is a fixed VC value, 0.25 meters per second, and omega of 0.5 radians per second. So by those two, I'm gonna go around the circle, and I'm gonna send this command to my Quanser. Now, how do I command the Quanser? If you go here and go inside this one, these are the two major blocks of Qbot. The first one is called HIL right. This is the block that sends the speed commands to the right and to the left motors, so you can directly control the motors by speed. You don't even need to give it a torque. So you don't go into the kinetics. You just control it directly with kinematics, and that is a big advantage. So you just give it right and left velocity through V and omega, and then when you want to read the rotations of the wheels, you use this HIL read block, which, as you can see, gives you right and left encoders. It also has other sensors like gyro, bumper, and so on. So it has a heading sensor, a gyro, if you want to do dead reckoning, not just odometry. You can use that. The important thing is when you read the encoder values, they are not basically in radians. They are just a number. And that number is between 0 to a little bit over 1,000, and you have, or 5,000, sorry, and you have to convert that number into radian. So you have to basically divide that number by the maximum count and then multiply by 2 pi, and that will allow you convert it into radians. Okay, so wherever you use these readings and you want to convert it into radians, in these blocks, you see a bunch of gains, and these gains are there to go from count, right, to what? To radians. And if you look here, you can kind of see the number that you have to have, okay? So you have a 52 and you have a 49.58 and so on. So you can read these numbers. Now, I might be wrong in telling you exactly how many, how much is the max count on each encoder. So here I have to correct myself. The maximum count is 2,578 per one revolution. So whatever number you read from the encoders, you divide by that number, multiply by 2 pi to convert it into radian, okay? 2578 is the maximum count in one full revolution, okay? Keep that in mind. And also the Kinect workspace on IR, not exactly the laser. So that is an IR plus a regular camera. So I want to make sure that I don't give you wrong information. So here I do odometry and I calculate my position and orientation, or the pose of the robot. And then once I have X, Y, theta of the robot calculated along with the depth data that I send, I can send them to a function that creates the 2D occupancy grid map, converts it into an image, and then with this block called display image, I can see the map in real time, okay? And by the way, since the depth data and the XY theta data, which are coming from encoders, they are not with the same rate, right? So your connect works at a different rates than encoders. To make sure they all work together, you always use these rate transition blocks, these guys, okay? So that the system can work together. And these Quansers, they have the Wi-Fi antenna, and so they communicate with Wi-Fi. So once you have all of this set up, then you go under the Quark tab. You need to make sure under the preference here that the IP address of the robot is provided, and each robot has an IP address. So you provide the IP address, and once you have that fixed under the preferences, you can click here and say monitor and tune. And it is going to compile it, make executable files, send it to the robot, and it is going to, there we go. It is going to start moving. So as I said, it moves on a small circle, and it scans the environment. Okay, it should not get anything outside the range of 0.5 to 5. Anything like that, it considers it as invalid. So if it gets too close to the objects, it is not going to give you reliable data. Now, if we go back here and look at the occupancy grid map generated in real time, there we go, look. So the black spots are the spots that are taken, okay, the objects. The white spots are the ones that are free, and the grays are the ones that are not scanned yet, or there is no data available for them. And so you clearly see here, if you look, we have two lines, right? Two big lines. Let me show you this one and this one. These corresponds to those folding tables that I have. And then these two small spots are the two robots on the table. And then I have two boxes on one side, and then that yellow kind of box cap on the other side. So I have a total of 5 separate individual disconnected objects and 2 tables that are kind of connected to each other. And then all of these things, these black spots that you see between them, these are the walls in the back. Okay, so these are the walls in the back. Now behind those tables, it cannot see really much. So sometimes it might show some spurious data like that, but the matter of fact, it cannot really go much behind those tables unless when it makes a numerical mistake or something, or that small gap that you see between the tables, that's probably an area that it can go a little bit behind them. The other important thing is, pay attention, this is a 2D map, so it only scans objects that are at the same height at the connect, okay? So if the object is on the floor or above the height of the connect, it is not going to get that. It's just a section of the 3D world. Now, of course, this guy can give you an image of depth. So if you want, you can really convert this to a 3D map if you want to. But in this case, my goal was just to show you the 2D section of it. And remember, we can always go back and convert this to an occupancy grid map that is 3D. The best thing about the Quanser robot is everything can be done with Simulink and with the blocks. You don't necessarily need to write down a lot of code, although some of these blocks that you see are user-defined blocks in the model, and there is code inside some of them, okay? So some of them, if you go and look at them, they are user-defined functions like that, and there is some code for them. But for the most part, many of them are built-in blocks that are available for you and that can reduce your total preparation to run something with the robot. So hopefully this video was useful to you. One last thing before I finish the video, remember that when the robot captures the depth data, okay? It is with respect to the robot frame, the robot's attached frame. X, Y, and theta. Remember, for a mobile robot, X is forward, Y is to the side, and Z is upward. But when you put those data together and create a map, you have to transfer them back to the world coordinate, and that's where you need that X, Y, and theta in order to be able to transfer them back to the world coordinate at any position and orientation of the robot. Then you can accumulate them and you can get an occupancy grid map like this. So hopefully the video was useful to you. I'll see you in the next lecture. Thank you.